Basically for better.
All right, so we have 11.4 that we sort of scratched the surface with on Friday, and that we're going to finish up today. And then tomorrow we start review. Wednesday we finish review, and Thursday we have our last pre-calc test. Sounds good, right? Yeah. And you hand in your last pre-calc homework. Sound good, right? Friday, I'll miss you and you'll miss me. So we're not going to see each other Friday. And then on Monday, we will start review. And we'll review for all of next week. And then we'll have a long weekend. And then you'll come back on Tuesday with any last questions. And then you'll start your exams and other classes. And then 2 weeks from today, 3 weeks from today, you'll find yourself sitting in the gym taking your pre-calc exam.
Wow.
Middle school has their graduation ceremony in the Riley Theater.
So what are we going to sit on?
You'll sit on the floor. That's okay, right? Yeah. They will actually have, they'll have the luncheon table set up for graduation. So they're going to be big tables and chairs. So it'll sort of be like going to your prom, except instead of having a good time, you'll get to take an exam. And it will be in the gym.
Wait, you're serious about the gym, right?
I'm totally serious about the gym.
Wow. Wow.
Wait, so we'll have get free food?
No, there'll be no food involved. All right. Nope. Definitely not going to happen.
Yeah. To have an exam that you can take in the time you want, and everyone working together, but the exam is like an hour. No.
Sounds fun. All right, so this is the sum of a geometric series. So if you have a series where you're adding up geometric terms, that's going to be the sum. And we actually did that on Thursday. We went over questions from Thursday's homework on Friday, so we're feeling pretty good about that. We sort of left Friday asking what would happen if we had an infinite geometric series. And you can think of lots of infinite geometric series. Here might be one example. If you had like 1 plus 2/3 plus 4/9 plus 8/27 plus 16/81. How am I doing? Does that look like a geometric series? All right. That geometric series, we can keep adding and adding and adding terms. We can add up an infinite number of terms, but it actually converges. And by converges, we mean it approaches a limit, and it doesn't get any bigger than that. And that's because the R value is between, we said 0 and 1. We could actually say between -1 and 1. So it will converge if the R value is between -1 and 1. If R is bigger than 1, like if we're looking at like 2, 4, 6, 8, 16, you say that diverges. It gets bigger and bigger and bigger. And maybe can we just look at this on the calculator? Okay, so before we add them up, let's just get the sequence. So if I want the sequence for a geometric, let's see, I think I'm going to go to mode and go, I'm in function, okay. So where's my sequence button?
Oh, it's on the, okay, second stat.
Alright, second stat. Alright, there's the sequence button. Let's hear it for Adrian for taking notes. That's awesome. Way to be. So if you type in sequence, you have sequence and you need to tell your calculator 4 things. You need to tell it the rule, you need to tell it the variable, and where to go to and from. Alright, so what's the rule if we go back to the sequence that we had, 1, 2/3, 4/9? What's that rule? Alright, so definitely R equals 2/3. Whoops. What happened there? Let me try that again. R equals 2/3. So A sub n equals
1 times n minus
2/3 statement.
and it's
yeah. All right. So as a class, you put it all together, right? That was good. Like Adrian said n minus, then I said 2/3, then Dan said raised to the n, and then Gabby said -1. So that was good. That worked out. None of you would have been right on your own, but together you stand. All right. So that's the rule. So if I go back to my rule, do you mind if I skip the 1 times? I'm just going to write 2/3 raised to the x minus 1. All right, what's the variable? X is the variable, and we're going to start with the first term, so x is 1. And let's just, for now, do the first 10 terms. All right, and then I know we're talking about an infinite geometric series, so eventually we want to talk about an infinite number of terms, but let's just talk about 10 for now. And let's see how we did. 1, oh, I wonder if, hold on, don't go anywhere. If I go to math fraction, 1, 2/3, 4/9, 8/27.
how do you do that?
It's so cool.
If you have an answer and then you type in math and go to your fraction, it will take your answer and convert it to a fraction.
Nice.
Learn something new every day. All right, so there it is. That's the series. That's the sequence, rather. We want the series. We want to add it up. So let's add them up. I need the sum. Adrian, where's that sum button? All right, second stat. Math. And there's the sum, 5. And I can do second answer. So add up all those numbers for my answer, and I get 2.94797. Now we've only done 10 terms. Do you want to take a guess at what we're getting close to?
3.
I think so. All right. We could also do this. Let's see. I'm going to do second enter, second enter, second enter. Okay, so I'm going to go back to that sequence. And in front of the sequence, I'm going to go to second insert. I'm going to insert second stat math sum. So I'm going to sum the sequence. And instead of doing 10 terms, what should we do? Like, will 20 terms convince you? 50 terms?
1,000.
Adrian's been taking notes, so 35 it is. Now, the more you use, the longer it's going to take, because the calculator is actually going to add these up. So 35 is going to take a little bit. You're going to have to wait for your calculator to think. It's thinking, it's thinking, it's adding, it's adding. It's thinking 2.999999979. You think you are right, we're getting closer to 3? Okay, so this series converges to 3. It doesn't matter. We can keep adding terms. This series isn't going to get bigger than 3. And that has everything to do with the fact, think about how big the terms are we're adding. When you get up to 35th term, how big is that? It's teeny tiny. Like, that's 2/3 raised to the 34th power. Look at that. Times 10 to the negative 6th. Move the decimal 6 places this way. It's teeny, teeny, tiny. All right. So back here. So look, if n goes to infinity, what's the limit as n goes to infinity of s of n? Well, we talked about this on Friday. If r is between -1 and 1, what's a fraction between -1 and 1 raised to a really big power? What happens to that number? Yeah, tiny, tiny, tiny. This gets closer and closer to 0. If you take a number like 2/3 and raise it to the 34th power, you get a tiny number. So we end up with a over 1 minus r. And we mean the first term here. And guess what? The same thing we did on our calculator. What if we did here? What if we just plugged in? What's the first term over here? What's r? I can even do this in my head. 1 divided by 1 minus 2/3 is 1/3. Hey, what do you know? Yeah.
Is that better if you do it by hand?
So this would be like, using a formula, doing it mathematically, sort of coming up with what it is. And the other way we did it was using our calculator, right? Sort of seeing what it was getting closer and closer to, right? Is that okay? Questions? Go ahead.
Actually, so like if back on the other sheet here, if that r to the n, if that's like not 0, let's just say, would you still like plug that into the formula?
So this only works if the absolute value of r is less than 1, if r is between -1 and 1. If r is between -1 and 1, r to the n will always go to 0. If r is like 3, then we already know that it's not going to converge, it's going to diverge. It's just going to go to infinity or negative infinity. When you think about it, it's sort of like an exponential equation, right? Exponential equations can either grow and get bigger and bigger and bigger, they can grow and get negatively bigger and bigger and bigger, or they can decay, right? They can get closer and closer to asymptotic to a number. And that's sort of what this is. And if you think about geometric and exponential, they go hand in hand. Grab your classwork. You want to do, what do you want to do? 13 or 14? 13. So we'll do 1 to 13 and 1 to 14. All right, let's do 13b. No, I don't want to do that. Do 13a. All right, go. Do 13a. I'll give you like 2 minutes. Maybe a minute. Tally, a sub 1, what's the first term?
A sub 1?
Yep. Say it loud and proud. Much better. Janelle, what's R?
1/3.
Is that a question or a statement? Good. All right. I need to now come up with the sum of this infinite series, and I also need to write it in sigma notation. Janelle, call on someone to pick one of those 2 tasks. It's sort of backsies, but I'll let you go because there are only like, 6 of us? Oh, all right, good. Which one do you want to try?
Well, I was going to try the sigma.
Okay.
So the top would just be infinity.
All right.
And then for I,
Do you want to use I's or N's? I don't care. Okay. Because my 1's and I's look too similar. Or my I's and 2's look too similar or something. All right.
would it start at 1 or would it be 6?
Let's start by putting the formula in, and then we can try 1 and we can try 6. So it's sort of like a courage for the deed thing. So what do you think the formula is going to be?
So I would just use like the A times 1, right?
Yeah.
So it would be 6 times 1 minus.
Tell me. All right, go ahead.
Or 1/3.
I was thinking
Oh, like 1/3 and minus
1/3.
like
to the n minus 1. I would agree. All right, so that's what the general geometric is going to look like. So now your question is, what should n start with? What's the first index for n? And the debate was, should n start with 1 or start with 6? So if n is 1, my first term is I plug 1 in for n. 1 minus 1 is?
0.
Anything to the 0 power is?
1.
6 times 1 is? That seems like it works. If it didn't work, I could try putting 6 in. In this case, I can see it would be 1/3 to the 5th power, and it wouldn't work. All right. But, courage for the deed, right? We tried it. This one was nice. We got it right the first time. All right. Adrian, calling someone to actually find the sum for us.
Alright, so would it be 6 times 1 minus 1/3 n over 1 minus 1/3?
Talk to me about what n is in this case. What are we adding up to? How many terms do we want to add up? Definitely. So if n is infinity, if I'm trying to find out the sum of an infinite number, 1/3 to infinity, if I take 1/3 and raise it to a huge power, what's that become?
0.
That becomes 0. So I'm left with the first term, which is 6, over 1 minus 1/3. Okay, and that's your general formula. A over 1 minus r. Well, 1 minus 1/3 is 2/3. Flip and multiply. What's that? 18 over 2, 9. We get 9 for our answer. Questions? You want to talk about it? You know what this reminds me of? It reminds me of that drug concentration project we did, where we kept adding up like a whole bunch of terms over a long time. We should do a problem like that soon. But you guys said 14 first. Do you want to ask a question? Janelle? Kaylee? Dan? And there's no confusion as to which Dan we're talking about anymore.
Yeah.
I didn't say that.
No, I did, because I don't like it when he sat right there and you say, Dan, and never call him. He's a nice guy. I don't like him. What?
Gabby, A or B? All right, so we're going to do A. In order to find the sum, I need the first term and I need the R value. All right, so the first term for A, calling someone, Gabby, is 10. Right, because anything to the 0 power is going to be 1. All right, I need the R value. Kaylee, calling someone? -1/2. Definitely. Good. So let's plug it in. We get 10 over 1 minus -1/2. Well, 1 minus a negative is the same as 1 plus. So that's 3/2. So I have to take 3/2, invert and multiply. What's that, 20/3? And that's your answer. Sort of nice. Like, not saying that you can't do sum and do the sequence on your calculator, but don't you think that formula is sort of like quick and easy? Let's try the next one, which is a little harder. I'm not going to find the answer, but we can find out what A and R are. Kaylee, calling someone for A or for R?
A is 3.
So
Oh,
close.
wait, oh,
So
okay.
close.
You tricked me.
I did. It was nice. I'm glad I did.
I don't know. I don't know this. It's like 0.12.
Is that 3/25?
1. Wait.
I can put it in fraction.
Oh, yeah.
Yeah, 3/25.
So, in this case, be very careful because the first term is when n is 2, not when n is 0 or n is 1. So you have to plug in 2 for n for the first term, and that's 1/25 squared. It's 1/5 squared, which is 1/25 times 3 is 3/25. Dan, calling someone for R.
That would be 1/5.
Perfect. All right. Do you want to look at drugs or money? All right. We'll do. I think we'll have time to do both. Let's take. What are you all laughing at? All right. So if we look at money, what is this? A junior high five?
No, it's a bio, not having bio high five. Oh, true, sorry. It's college, too. Sorry,
How'd you not take bio?
No, I do take bio, just not that.
Oh, okay.
We're all in the same class.
Yeah.
We're
You do bio on the side,
Yeah.
dissecting animals in your spare time.
Never.
All right. So when let's see. When you're what?
We're all in the same class.
Guess what? All 6 of you are in the same pre-calc class.
Wow.
When I don't know, a professional athlete is given a signing bonus. They might be given a signing bonus of $10 million paid out over 5 years, meaning that they'd get $2 million every year for the next 5 years. But guess what? That's not actually $10 million. I know it sort of sounds like $10 million, but $2 million next year is not the same as $2 million this year.
How do you mean?
Interest in the banks.
Right? Like, I can buy a lot more with $2 million right now than I can with $2 million next year. Inflation, things are going to go up. And not only that, but if I have $2 million right now, I could put it in the bank and have more than $2 million next year. So if someone tells you they're going to give you $2 million next year, that's the future value of that money. The future value is $2 million, but the present value of that $2 million is actually going to be less. So sometimes we talk about the present value of money that you're going to get in the future. So we're going to talk about the present value of money. All right. Let's take like a 5% annual interest, and let's ask like, what is the present value of? Actually, I have a better idea. I'm going to do 6% interest. And let's do the present value of $100,000 that's payable 5 years from now.
You say payable 5 years from now. You mean all that would be paid within 5 years, right?
So, I mean, at the end of 5 years, I'll give you $100,000. It's like your gift for graduating college. There you go. You graduated college, I'll give you $100,000 to start off.
Usually you like have that.
Yeah, I know. It doesn't make the story as interesting. So $100,000 in 5 years, that is not what it's worth now. The present value of that money, is it going to be more or less?
Less.
It's going to be less. Okay. As a matter of fact, would you be all right if I told you that the $100,000 is equal to some amount times 1.05 raised to the 1.06 raised to the 5th?
Yes.
Does that make sense? Like the $100,000 then is worth some amount right now that I could actually get 6% interest on for 5 years. Is that all right? All right, go ahead. Find that out for me. What'd you get? 74,728? 25. All right. So about $75,000 now. So would you rather have $75,000 now or $100,000 in 5 years? It's pretty much about the same. Right? That $100,000 in 5 years from now has a present value of $75,000.
Wait, so you're saying that the 0.06 is
Oh, wait.
I'm sorry.
No, it's fine. It's good.
P stands for present value.
I guess so. Or the principal, I guess. I mean, what you'd put in the bank right now to have the same amount then.
And 0.06 is the amount of interest being paid on it?
Mm-hmm.
And then that's going to show you, even though you've got the interest, it's still going to be worth significantly less in 5 years.
No, well, so I guess actually there are two things going on. There's this fact that you can have interest going, and the fact that you're also going to have inflation sort of working against you. So if we were to just simply talk about interest, I mean, what's interest there for? It's there, in essence, to account for inflation, except it's like inflation plus a little bit, because that's how banks make their money, that plus a little bit, right? So if we were just looking at interest, we would say, like, yeah, having $100,000 then is the same as having $75,000 now. Because you could take the $75,000 and invest it, and it would grow to $100,000 then. It's actually not also taking into account inflation. So it's sort of, I don't know, maybe I complicated the problem a little too much by saying that. Is that all right? Okay. I want to come back to the money problem. We can do that, but let's talk about drugs for a little bit. I was thinking like ibuprofen or something. Let's do 200 milligrams every 12 hours. And let's say after 12 hours, 5% is still left in the bloodstream. So, this should sound like your project. How much is left after the 3rd dose? After the 10th dose? In the long run. All right. Well, after the 3rd dose, how much would you expect? More than 200 milligrams or less than 200 milligrams? Did anyone say anything, or was that the wind blowing?
No, that was more.
More. I think more, right? Because you're going to have 200 plus a little bit left over from the first tablet plus a little left over from the second tablet. Does that make sense? So, could you actually say, like, the quantity after the first tablet's 200, the quantity after the second tablet is 200 plus 5% of 200? The quantity of the 3rd tablet is 200 plus 5% of the second tablet plus 5% of 5% of the first tablet? Isn't that true?
Yeah,
because every 12 hours,
Oh yeah, so it's going down in even more.
right?
Right.
And then the 4th tablet, right, it would be 5% of 5% of 5% of the first dose, right? And actually, what does this look like? Try again. You're so close. Try again. No, you're really close. Series. That's a geometric series. We're adding up geometric terms. And as a matter of fact, if it's a geometric series, I'd love to know what A and what R are. R. What's the first term, Kaylee? Definitely. Calling someone for R?
0.05.
0.05. All right. So let's try it out. The sum of the first 3 terms should be 200 times 1 times 0.05 to the 3rd, all over 1 minus 0.05. All right, do that. That should be the first three terms. And let's see. Did you get 210.5? Awesome. Alright, so we get 210.5 milligrams. And as a matter of fact, if you actually did the three terms and just added them up, you'd see you'd get 210.5 milligrams. Alright, what about after the 10th dose? Well, the only thing you have to change to do the 10th dose is do 0.05 to the 10th. Is it going to be more or less than 210.5? More. Go ahead, do it.
Like 210.526.
210.526. Do I have a second on that?
Yeah.
All right. And we can now look at the long run. And remember, if we want to look at the long run, an infinite number of terms, all we need is the first term and the rate, and it's just the first term divided by 1 minus the rate. So all I need to do is 200 divided by 0.95. And in the long run, 210.5263. Something, something, something. Let's see if I can be clever about this. Let's clip that. And, oh no, that's not where I wanted it. Alright, well that did not work. I know. I wonder if I can paste it again. Alright. That's not where I wanted it, though. Oh, well. Alright. So you get 210.5263. Wouldn't that have been really convenient for that drug dose project? Mm-hmm. How cool would that have been? You could have just done A over 1 minus the rate and found out what it was approaching in the long run.
Let's say with like the number, would you have taken off points for the addition?
I don't think so. Yeah, wouldn't have that been mean, sort of? Like, penalizing you for something you knew?
Maybe you should do that, you just trying to suck up. You don't have to you. That's how it works.
Alright, so look. Infinite geometric series, right? So we've talked a little about money, we've talked about drugs now. Isn't that convenient? It totally is. 5 more minutes? Is that true? Can we go back to money?
Let's do it.
Alright. So the money problem that we looked at was actually, well, sorry. Do you want to ask any questions? Sure? Gabby? Tolly?
Yes.
Question? No. All right. Let's look at like what should we look at? I don't know what we should look at. Let's look at $15 million paid out over 5 years. So you're going to get $3 million every year. And the question is, if you get $3 million every year for 5 years, is that worth the same to you as $15 million right now? That's the easy part of the question. Say it loud and proud. Definitely not. Like, would you rather have $15 million right now or $3 million right now than $3 million in a year, $3 million in a year, $3 million in a year, and $3 million in a year. Yeah, right now. Give it to me now. I want it right now. Right? Because I can invest it now, I can spend it now. It's worth more to me now than it is later. So actually, one of the questions we could ask is, what is the present value of getting $3 million every year for the next 5 years? What is that present value? And it all goes back to this. The present value is always going to be the amount divided by 1 plus the rate divided by n. So that's sort of the generalization of what we did when we were just looking at that $100,000. Can I get a new page up? Okay. So would you agree that the first year's the $3 million you get right now is actually worth $3 million? All right. Plus the $3 million you get next year. How much is the $3 million that you're going to get next year worth? Go ahead. I'll give you like 30 seconds. You can either give me the exact number, or you can tell me in general what it would be worth, like the general formula. If I get it in a year, how much is that worth to me now? Is it going to be worth more or less? Now. It's going to be less now, so it's going to be less than 300 million. So how would I figure that out? 300 million a year from now is worth how much right now? And you did a problem like this when I said $100,000 5 years from now is worth how much right now? So if I ask you 300 million a year from now, how much is it worth right now? You can tell me.
This is the interest, right?
Oh, do I have to tell you that? Yeah. Oh, what do you want to... You're totally right. What do you want the interest rate to be?
6.25.
That'd be nice.
I'll take Kaylee's conservative 6% annual interest. I'm sorry. You guys kept flipping your papers back and forth, and I'm like, all right, do it. Come on, you're not doing anything. And then you're finally kind enough to tell me that I didn't give you enough information. Janelle, thoughts or ideas? Did you get a number? What'd you get?
I got 2,430,130.
All right, so 283 million. Is that what it is? No, it's not. No, move the decimal over. 283,000. No, wait.
2,830,000.
Oh, that's what you said. That's not what I said. That's what you said. Yes, 2,830,000. So it's worth less. I totally agree. All right. What did you do to get the number?
I just did 3 million divided by...
Perfect. So that's how much next year's $3 million is going to be worth. And the following year, I'm going to take 300 million. What am I going to divide by? 1.06. Yeah, 1.06 squared. All right, we'll come back to the $3 million over 5 years. Nice work today. I'm impressed. Wow. Go juniors who take bio in both classes.
And plus Janelle.
Yeah, she takes it in the other class, right?
It'll be individual.
I said
Oh.
Except for
who take bio in both classes.
Bio